Happy Monday, everybody. I thought I'd start today off with a couple of shout outs. We'll do this each time that we do notes. Today I'm going to do 3 shout outs. First one, let's just pick a name. Shout out to Matt for always being a great help at his table, helping to move things along. And when the drumming got too loud at the table, he joined in. Thank you, Matt. The next shout out goes to, Lily, for not getting mad at me at the beginning of the year for pronouncing her name wrong, and for always keeping tabs on Isabella and how often she went to the bathroom and came late to class. It's always a great help. And then our final shout out will go to today, shout out to David, because he just had a triumphant dunk in basketball over Tyler. Great job, kids. All right, so moving on. Today's goal is that everyone at the end knows the different groups of real numbers. So we're going to classify different types of real numbers. All right, so all real numbers, and real numbers are any of the numbers that fit onto the number line that you've seen in the classroom many times before. Not all numbers are real. There are numbers that are on different number lines, but the numbers that we're going to use and that you'll use through Algebra 2 are real numbers. They're broken into 2 main groups. The first group is rational numbers, and the second group is irrational numbers. So all real numbers are either rational or irrational. Rational numbers are the numbers that you generally like. They're numbers that you can write as a fraction. And that's why we call them rational, because ratio means fraction. As a decimal, if you can write them as a fraction, that means as a decimal they either end or they repeat. And you learned the trick last week for how to write a repeating decimal as a fraction. So rational numbers are numbers that you can write as a fraction, and as a decimal they either end or they repeat. The other group of numbers, the irrational numbers, are numbers that you can't write as a fraction. There's no fraction that represents them. The most common irrational number that you're used to seeing is pi. There isn't a fraction that represents pi. There's one that's close to it, but there's not one that is exactly pi, because pi is a decimal that goes on forever and never repeats. So as a decimal, they never end and they never repeat. The other irrational numbers, there are so many. If you simplify a radical by doing the factor tree and not everything goes outside, you still have something left on the inside, that number is irrational. So square root of 2 is irrational, because if you go to simplify it, not everything's coming outside. Square root of 17 is irrational, because if you simplify it, not everything goes outside. Square root of 20 is irrational, because if you made the factor tree, part of the 20 would come outside. The 2 would come outside, but the 5 stays in. If you have anything left on the inside, it's an irrational number. So now we're going to talk about the rational numbers. The rational numbers, I'm going to scroll. Okay, so rational numbers are numbers that you can write as a fraction. And if a number is rational, there's other categories that we can classify it as. So here's all real numbers. They break into 2 categories. Rational numbers have more categories. The most basic category is the category of natural numbers. And natural numbers are just the numbers that you would count with, and sometimes we call them counting numbers. So 1 is a rational number, and it's also a natural number. 2 is a rational number, and it's also a natural number. 3, 4, 5, and so on. whole numbers is another category of rational numbers. Whole numbers are all the counting numbers plus the number 0. So 0 is the only number that's a whole number, but is not a natural number. So the only difference between these two groups of numbers is that this one includes the number 0. So there are many numbers that have more than one category. And then the other category of rational numbers is integers. Integers are all the whole numbers plus their opposites. So these three types of numbers you like best because they don't involve any fractions or decimals. They work, these are the numbers, when you get these answers, you think that problem works out perfectly because you get a nice number. So now we're going to look at a group of numbers and we're going to see if we can categorize them into all the different groups that they belong. Okay. So to start off, all the numbers that we're going to ask you about will be real numbers. And for those of you who are interested, numbers that aren't real would be square roots of negatives. Square root of -1. In math, we call that the imaginary number. We use the letter I for it because there isn't a number that multiplies by itself to give you -1. Square root of 9 would be 3 because 3 times 3 is 9. But there isn't anything that will multiply by itself to give you a negative number. So that's a whole different group of numbers, the complex numbers we're not going to talk about. So all of the numbers, unless we give you one as a trick, will be real. So 0 is a real number. 0, now we need to decide if all of these numbers are either rational or irrational. They're only going to belong to one of these two. 0 is rational because you can make it into a fraction. You could write 0 over 1 if you wanted to, and that would equal 0. 0 is also an integer. 0 is also a whole number, but 0 is not natural. You don't count with the number 0. So natural numbers are the numbers you would count with. -3 is a real number. Now we need to decide, is it one of these two? It is rational because you could write it as a fraction. You could write -3 over 1. It's not irrational because it's rational. It is an integer because integers are all the whole numbers and their opposites. This is the opposite of the whole number 3. It isn't a whole number because it's negative. Whole numbers only include the positives, and it's not natural because you don't count with it. -1/2 is our next number. -1/2 is real because it's not the square root of a negative. We have to decide between these two, and we're going to choose rational because it is a fraction. Integers have to be numbers that don't include fractions, so it's not an integer, so it's not a whole number, and it's not a counting number or a natural number. 0.09 is a real number because I could write that as a fraction. I could write 9 over 100. Of these two, I'm going to choose rational because I can write it as the fraction. It is not an integer because it's a decimal number. It's not a whole number and it's not a natural number. Pi is a real number. And of these two, pi is irrational because you can't write it as a fraction. Pi is a decimal number that goes on forever and never repeats. And if it's irrational, it can't be any of those categories, so we can stop there. -pi is also a real number. And of these two, we'd have to choose irrational for -pi because, again, it's a decimal number that goes on forever and doesn't repeat. 3.14 is not pi. It's a rounded decimal number. It is real. But because it ends, we can write it as a fraction. So it is rational. But because it has a decimal part to it, it's not an integer, it's not a whole, and it's not a natural. Square root of 24. If you get a radical, you want to see if you can simplify it first. This would be a 4 and a 6. a 2 and a 2, a 2 and a 3. So I have a pair of 2's that would come outside. 2 times 3 is 6, so the 6 would stay inside. So if I have something left over on the inside, this is going to be an irrational number. So we know it's real, and now we know it's irrational. And if it's irrational, it's none of those. For number 9, 0.2 repeated, if you remember from what we did last week, 0.2 repeated is 2/9 as a fraction. So it is real and it is rational. But because it's a decimal number, it's none of those others. And for 10, 10 is 0.9 repeated. And if you watched our TikTok or you remembered last week's lesson, 0.9 repeated is 9/9, which is the whole number 1. So this is a trick question. This is actually asking us to classify number 1. It is real. It is rational because we can write it as a fraction. It is an integer. It is a whole number, and it is a counting number or a natural number. So now there's a couple of other things that you can do on this form to practice and get good at this. We want you to be able to classify numbers like we just did on this chart. Have a good day.